Welcome to this video on solving multi-step equations. I invite you to remember that anytime you're solving an equation, the goal is always to isolate the variable. The only difference with multi-step equations is that it might take us a few more steps. It might take a little bit longer to get from the equation we're given to x equals something, to isolating the variable. So as you can see here, I have a list of steps that we can apply anytime we have to solve a multi-step equation. Now, just like any sort of process or troubleshooting guide, we have to remember or realize that we might not always need all of these steps. So let's get started with this first problem. It says 3 parentheses 4x plus 2 close parentheses equals 30. So according to our process, the first thing we need to do is to apply the distributive property. And remember, this is only appropriate if we have some parentheses. And in fact, we do. We can distribute this 3 to the 4x and to the 2. So we have 3 times 4x, and if you want, you can write it out. 3 times 4x plus 3 times 2 equals 30. You don't have to write out the step. You could just write 12x because 3 times 4 is 12 and 3 times 2 is 6. So now we have 12x plus 6 equals 30. Okay, so let's look at the second step in this list. The second step asks us to combine like terms. Remember, you can only combine like terms if you have them on the same side of the equation. So let's look at this. Are 12x and 6 like terms? They are not, because one contains a variable and the other does not. On the other side, we only have one term, which is 30. So in this case, we don't need to apply the second step. We can move right on to the third step, which is to move all variables to one side of the equation. Again, if I look at this, I can see that there's only one term in this problem that contains the variable, which is the 12x. So I don't need this step. Okay, so let's go to step 4. It says move all constants to the other side of the equation. Now, if I look at my constants, I can see that I have a plus 6 on the left side of the equation and I have a positive 30 on the other side. So this is a step that is useful and helpful to me. Additionally, I want to remind you it's always a good idea to draw a line between or through your equal sign to keep track of the left side and the right side of the equation. Okay, so how can I get rid of a plus 6? In other words, I want to isolate this variable. I want to isolate my x. So I'm always moving numbers away from my variable or my variable term, not towards my variable. Okay, so you might be tempted in this problem to subtract 30 from both sides. Okay, but that's actually going to be the opposite of what we want to do, because that's going to move numbers closer to our variable instead of away from our variable. Okay, so we undo plus 6 by subtracting 6 from both sides of the equation, because remember, addition and subtraction are inverse operations. Then we can bring down the 12x. Plus 6 minus 6 is 0, so we just have 12x. These cancel out. And then 30 minus 6 is 24. Okay, so now we have isolated our variable term. Our variable term is 12x, but now we need to get x all by itself. So how do we get rid of our 12? Well, 12x literally means 12 times x. What's the opposite of multiplying by a number? Well, the opposite of multiplying by a number is dividing by that number. So we need to divide both sides by 12. So now we have x is equal to 24 over 12, or x equals 2. So the last step of this is to check our work. Okay, so let's go back to our original equation. We have 3 parentheses 4x plus 2 close parentheses equals 30. Okay, so in place of x, I am going to write a 2, and I'm using parentheses around my variable just to maintain the fact that the 4 and the x are being multiplied by each other. Okay, so it's going to be 4 times 2. So now we have 3 parentheses, 4 times 2 plus 2, close parentheses, equals 30. Okay, so I invite you to remember, please excuse my dear Aunt Sally. We need to do what's in the parentheses first. So 4 times 2 is 8. We also have to multiply before we add. Okay, so we have 3 parentheses, 8 plus 2, close parentheses, equals 30. Of course, 8 plus 2 is 10. And lo and behold, we have 30 is equal to 30. And so that checks out, and we have verified that 2 is in fact the correct solution to this equation. So again, remember, we're going to work through these steps, but we might not always need every one of these steps. It depends on the actual equation. Let's do another problem. Here we have 4 plus 5x minus 3x equals 5 minus 9. So again, the first step is to apply the distributive property. I can only apply the distributive property if I have something that needs the distributive property. In other words, if I have a number multiplied by a set of terms in parentheses. I don't have that in this problem, so I don't need step 1. Now let's look at like terms. Do I have any like terms on the same side of the equation? So let's go ahead and draw a line down through our equal sign so that we can keep track of the two sides of this equation. If I look on the left side, I see that I have a positive 5x and a negative 3x. So without moving anything across that barrier between the two sides, I can just combine them. What is 5x minus 3x? Well, 5 minus 3x is 2x, so I can simplify that side of the equation before I do anything else. Likewise, you might notice that 5 and negative 9, or 5 minus 9, again, like terms. You can do that in your head or type it into your calculator, and you realize that 5 minus 9 is negative 4. Okay, so in this problem, we didn't need step 1, but we did need step 2. Now step 3 asks us to put all variables on one side of the equation. Well, where are the variables in this equation? I only see one variable term, which is the plus 2x. So we don't have multiple terms containing a variable that we need to move around. Therefore, we don't need that step. Okay, now it asks us to move all constants to the other side of the equation. So where are our constants? So notice I have a plus 4 on this side and a negative 4 on the other side. So what should we do? Remember, we always want to move numbers away from the variable. So in other words, I don't want to add 4 to both sides because that's moving values towards the variable. I want to move numbers away from the variable. So how do I get rid of this positive 4 here? Well, I subtract 4 from both sides. Now this is an easy mistake to make, so be careful here. So first of all, these cancel out. I bring down the 2x. What is negative 4 plus negative 4? It's not 0. They're added together. They're combined. So it's like I borrow $4 and then I borrow 4 more. Now I owe you $8. Okay, so be careful of that. Be careful of accidentally canceling values out that are actually cumulative. Okay, so now we have a one-step equation. We can do the last thing, which is to isolate the variable. And we can do that by undoing 2 times x. We undo multiplication via division. So the 2's cancel out. So we have x is equal to negative 8 divided by 2. And of course, that is x equals 4. So now, remember, you always have that opportunity to check your work. You can walk away from every single one of these problems knowing that you got the right answer. And we do that simply, let me draw a line here, by substituting our solution in place of x. So notice I'm sort of building a nest. I'm building some spots. Wherever I see x, I'm putting a blank or empty set of parentheses so that then I can go back, and I like to use different colors here, so I can go back and put a negative 4 in wherever I see an x. Okay, so I have 4 minus 20 plus 12, because a negative times a negative is a positive, equals 5 minus 9. Okay, so 4 minus 20 is negative 16. So we have negative 16 plus 12 equals 5 minus 9. Negative 16 plus 12 is negative 4. 5 minus 9 is negative 4. So this checks out. So remember, whenever you're checking your work, you don't want to stop until you have the exact same value on both sides of the equal sign. So if you stopped here, for example, right, you wouldn't be finished. You need to go until it's like a mirror, and negative 4 is looking in the mirror and seeing itself. All right, let's do another problem here. So here we have x plus 10 equals negative 5x minus 8. So let's go to our steps. So the first step, again, suggests that we apply the distributive property, but hopefully you can see that there is no opportunity to apply the distributive property. So we don't need this step. Then it asks us to combine like terms. Well, we have an x and we have a negative 5x, but are they on the same side of the equation? They're not. Again, it's always a good idea to draw this vertical line here to separate the two sides and to visually help you remember or realize, right, what is on which side. So we don't have any like terms on one side, so we can't do step 2 either. Well, what about step 3? Step 3 asks us to move all the variables to one side of the equation. So let's look at this equation and see where we see our variables. So hopefully you can see that we have an x or a 1x on the left side, and we have a negative 5x on the right side. So this is a good step for us to do. It's important to move all the variables onto one side of the equation. So I could do one of two things. I could subtract x from both sides of the equation, which is completely valid, or I could add 5x to both sides of the equation. Okay, again, both are valid. So in one case, I'm going to end up with a negative 6x. In the other case, I'm going to end up with a positive 6x. So let's ask ourselves, would we rather work with a negative coefficient or a positive coefficient? Personally, I would rather work with the positive coefficient rather than the negative one. Okay, so again, this is not a question of right or wrong, it's a matter of preference. So over the years, as I've taught algebra, I've suggested to students, if possible, try to get a positive coefficient. It's not always going to be possible. Okay, so again, this is a suggestion, this is a preference, this is not a right or wrong thing. So I am going to decide that I want to add 5x to both sides. So 1x plus 5x is 6x, so I have 6x plus 10 is equal to negative 8. Okay, then the steps ask me to move all constants to the other side of my equation. So I'm going to move the 10 to the other side of the equation. Why am I moving the 10 and not the negative 8? Well, quite simply, I want to move values away from the x, not towards the x. If I move the negative 8, I would be moving it towards the variable, and I'm trying to get the variable all by itself. Okay, so negative 8 plus negative 10 is negative 18. So I have 6x equals negative 18. And so then the last thing to do is to isolate my variable. I do that by dividing both sides by 6. So I get x is equal to negative 3. Okay, now I've been mentioning that, of course, you can always check your work, but I'd like to take this problem as an opportunity. Instead of demonstrating one more time how to check your work, I'd like to show you what would have happened if, instead of adding 5x to both sides, what if I had decided to subtract 1x from both sides? I just want to show you that that would also work. Okay, so let's subtract 1x here, subtract 1x here. Okay, so I'm drawing this line here. So I have 10 is equal to negative 6x minus 8. Okay, so again, I don't want to move the 10 here. You do not want to do that. You want to move the 8 because we're trying to move things away from the variable, not towards the variable. So I need to add 8 to both sides here. 10 plus 8 is 18. 18 equals negative 6x. Divide both sides by negative 6. We get negative 3 is equal to x. Notice that's the exact same answer that we got doing it the other way. Okay, so as we get more multi-step equations, there might be more than one correct way to solve the equation, just like there's more than one correct way to drive from maybe your house to school. There are many different correct paths. There are also a lot of incorrect paths, or there might be a way to drive, but then you sort of, it takes a lot longer, or you're doubling back on yourself. And the same thing is true with algebra. Okay, so I'm trying to show you the shortest path from step A, from the equation, to the solution.